3, and we're going to determine the empirical formula of a hydrate. So we take this idea, empirical formula, which is the lowest whole number ratio, but instead of the subscripts within the chemical formula of the salt or the water, what we're looking at is what is the ratio, how many salt units to how many water molecules. So this is the mole ratio that we're trying to figure out. What number do we put in front of the salt? What number do we put in front of the water? Now, we have a little bit of a typo. So this data right here, where it says 12.56, it needs to be 13.56 grams. A little typo there. Okay, so in order to do this, I like to analyze the data. We need to understand what each of these masses represent to help us do the calculations. So take a look. The 10.56 is described as the empty crucible and lid. So this mass belongs to the crucible and the lid. The second mass of 15.56 represents the mass of the crucible and lid. So the crucible and lid are on the balance along with the hydrate. Now it's a hydrate because it has both salt and water present. So this mass here belongs to the crucible, the lid, the salt, and the water. So this is before heating. After heating, the purpose of the heating, so to go from here to here, it's being heated, this drives out the water. So the last mass here, 13.56, still the crucible and lid are still present. So we still have the crucible and lid, but now it's the anhydrous salt, meaning the water's been driven out. There's no more water, and so this is crucible, lid, and salt. And in this case, FeCl3, that is the salt that is in this hydrate. We just need to figure out how many of these salt units and how many water molecules are present. So take a look. It wants us to calculate the mass of the salt. Well, I see that in the 15.56 there's salt, and I see in the 13.56 there is also the salt. So to solve this problem, using the mass that has the crucible, the lid, and the salt, and we remove the mass of the crucible and the lid. So for this problem, the mass of the crucible, lid, and salt is that corrected value of 13.56 grams minus the empty crucible and lid. So 13.56 minus 10.56 leaves me with a mass of 3.00 grams of the salt. Now I need to convert the mass of the salt to moles. So I need to go from mass to moles. So I know that I have 3.00 grams in that salt. Remember, I pointed it out, it's FeCl3. So I'm going to put its actual chemical formula here, which that is the salt. And we need to go from the grams to the moles. Well, 1 mole of this salt, we have to come up with its GFM. And so the GFM is you have 55.8 for the 1 Fe atom plus 3 times the mass of the chlorine, which is 35.5. And when you put that in the calculator, 1 mole of this iron 3 chloride salt has a mass of 162.3 grams. So when I do the math, 3.00 divided by that GFM value, I need to record the number of moles with 3 sig figs because my mass has 3 sig figs. And the mass, or the number of moles, is 0.018 0.84 moles of that FeCl3 salt. My next question asks me to calculate the mass of the water. So when I take a look up here, the only piece of data that contains the water is the one with the hydrate, the crucible, lid, salt, and water. It's the only piece of data that has the water present in it. So the crucible, lid, salt, and water. I want only the water to be present when I'm done with the mass, so I need to remove the mass of the crucible, lid, and salt. So it is the 15.56 grams minus the mass of the crucible, lid, and salt, which is 13.56 grams. So 15.56 minus 13.56 leaves me with 2.00 grams of water. And the reason I put those two zeros there is because these masses all go out to the hundredth, so when you add or subtract, you have to maintain the place to the right. So there needs to be those digits in the hundredth spot, even though they're zeros. This is my most right sig fig. Now I need to convert the mass of the water to moles. So I know that I have 2.00 grams of water. I need to go from grams to moles. 1 mole of water, we've memorized its GFM, 18.0. So 2.00 divided by 18 leaves me with 0.111 moles of water. So now I need to calculate that mole ratio. So I take both mole values. So I'm going to write salt here. So my salt's mole value is 0.0184 moles of the salt, and I need to divide it by moles. I also need to include the water, so my water is 0.111 moles of water, and I need to divide it by moles. So the rule is that you divide each one by the smaller. And in this case, 0.01, think of it as like 1 cent versus this one is 11 cent. Well, 1 cent is smaller than 11 cents. So I need to divide both of them by the 0.184. I got make sure I have my number written there correctly. And notice, because it's mole divided by mole, they are gone. And what we're left with is a ratio because there's no more unit. So how many salts? 0.0184 divided by 0.0184, I have 1 salt present. 0.111 divided by 0.0184, and it comes up as 6. So my ratio of salt to water is a 1:6 ratio. So I take that and I come up here. This is what I fill in. So for every 1 FeCl3, there are 6 water molecules present. Subscripts and coefficients of 1 we tend not to write in, but you might see it, you might want to put it in for yourself. So final best answer would not have this 1 written there. So it'd be FeCl3 big fat dot 6H2O. Now the other thing that we are asked to determine here is to calculate the percent by mass of water. So percent composition, we have a little quick recap. We have the quantity of the part divided by the quantity of the whole, and then we have to multiply it by 100%. Whatever we are asked to calculate the percent of, that is the part. Okay, so water is the part. So I have to have the mass of the water divided by the mass of the whole. The water is part of the hydrate, so the hydrate is the whole. So thinking through the numbers. So I already know from earlier that the mass of the water present in the present, or that was driven off, was 2.00 grams. So I have 2.00 grams. Now I don't have the mass of the hydrate, but the mass of the hydrate. This right here, because it's both the salt and the water, is the hydrate. So this is the mass of the crucible lid and the hydrate, which is the salt and the water both present. And then I need to remove the mass of the crucible and lid. So the mass of the hydrate equals the mass of the crucible lid salt water minus the mass of the crucible and lid. So we have 15.56 minus 10.56 grams. And that will give me the mass of the hydrate. So the mass of the hydrate, this difference, is 5.00 grams. And then we need to remember to multiply this by 100%. So 2 divided by 5 times 100. And on my calculator, it turned out to be 40.0% water.